Hello guys, in this video we are going to be looking at indices. It is an index number. An index number is a number which is raised to an exponent. We can also call the exponent index, and this index tells us how many times we have to multiply the number by itself. For example, I have 2 raised to power 5. That means we are going to multiply 2 in 5 places. Let's say 2 times 2 times 2 times 2 times 2. So here, the index is 5 and the index number is 2. The index number can also be called base, while the index is called power. Now, we must be familiar with how we write indices of different numbers. For example, between my ink, I have 8. Indices of 8 is written as 2 times 2 times 2, and that gives us 2 raised to power 3. So the indices of 8 is 2 raised to power 3. As you can see, 2 is the index number or the base, while 3 is the power. Another example is 16. 16 can be written as 2 times 2 times 2 times 2, and that will obtain 2 raised to power 4. So the index number is 2, while the power or the exponent or index is 4. If I have 9, 9 can be written as 3 times 3, and that we can write it as 3 raised to power 2. The index is 2, which is also known as the power. Then 3 represents the base or index number. Indices is an important concept in science in general. We apply indices and indicial operations in various aspects of physics, chemistry, and mathematics. So it is of great importance for us to be familiar with the laws that govern indices and its operation. So we are going to be looking at the laws of indices in order for us to be able to solve questions on indices. So the first law we are going to consider says that x raised to power m times x raised to power n, that will give us x raised to power m plus n. This simply means that when we have the same base, as you can see, the index number or the base, they are the same thing, but we have different powers and they are multiplying each other, we just pick one of the base, then we add the powers together. For example, we have 2 raised to power 5 times 2 raised to power 3. Following the first law, that means we pick the base since they are the same, 2, then we add the powers together, that's 5 plus 3, and that gives us 2 raised to power 8. Another example, if we have y raised to power 4 times y raised to power 3, obtain y raised to power 4 plus 3, and that will give us y raised to power 7. This is the first law that we have in indices. Let's look at the second law of indices. The second law says that x raised to power m divided by x raised to power n. We have x raised to power m minus n. This also explains the fact that if you have the same base x for different powers, changing, we have different powers. Just pick one of the base, since they are the same thing, then we subtract the powers. For example, we have 10 raised to power 2 divided by 10 raised to power 1. Let's say pick one of the base, 10, and we have 2 minus 1. That gives us 10 raised power 1. This law, which is law 3. Law 3 says that we have x raised power m multiplied by y raised power m. We obtain x multiply y everything of m. This is explaining the fact that here is the opposite of law 1. We are having different bases. The functions are having different bases, but the powers are the same. Since the powers are the same, we multiply the bases together. As you can see, they will pick one of the power, which is the index. For example, we have 2 raised power 8 times 6 raised power 8. Since the powers are the same and the bases are different, we just say 2 times 6 everything raised power 8, and that it will give us 12 raised power 8. Now let's look at law 4. Law 4 says that x raised power m divided by y raised power m will obtain x over y everything raised power m. Now this is telling us that if we have different bases but the powers are the same thing, as you can see they are having the same powers, we'll divide the base, the first base, we divide the second base, then both have the power m. For example, we have 10 raised power 5 divided by 2 raised power 5. Since they are having different bases but the same powers, that will just be 10 over 2 everything raised power 5, and that gives us 5 raised power 5. I can simply finish it up by saying 5 times 5 times 5 times 5 times 5, as we are look at in the beginning section. Let's look at the next law, which is law 5. Law 5 says that x raised power 0 gives us 1. This simply means anytime we have a number, variable, integer, and it is raised to power 0, we have 1 as the result. For example, 2 raised power 0 will give us 1. 7 raised power 0 will give us 1. 100 raised power 0 will obtain 1. 1200 raised power 0 will give us 1. This is the 5th law. Let's consider the 6th law of indices. It says that x raised power m everything of n. We are going to obtain x raised power m times n, and that will give us x raised power mn. What is this law trying to explain here is that if we have a function, if we have the base and we have the first power, everything is now enclosed in bracket to another power. We just pick the base, then we multiply the two powers. For example, we have 2 raised power 3 enclosed in brackets with another power called 5. We are going to have 2 raised power 3 times 5, and that will give us 2 raised power 15. Another example is if we have t raised power minus 2, everything enclosed in brackets with another power, we have 6. This one will give us t raised power minus 2 times 6, and we obtain t raised power minus 12. This is the 6th law. Let's look at the next law of indices. The next law of indices. The 7th law is x raised power minus n, that will give us 1 over x raised power n. This law is explaining that whenever we have our base and there's a negative power for it, this minus, let me change it, this minus alone signify 1 over. signify 1 over, then we still write our value. For example, I have y raised power minus 4, and we have, like I said, this minus alone signifies 1 over. So that means to remove the negative sign, just write 1 over. That is the meaning of the negative sign. Then I write my function, y raised power 4. Another example is, let's say we have 7 raised power minus 8. Like I said, the negative sign alone implies 1 over. Then we write our value back, x raised power 7 raised power 8 rather. Now let's look at this 8th law. The next law, it says that x raised power 1 over n. This will give us nth root of x power 1. Yes. So now this law explains that if we are having this kind of function, as the base is x, and we are having 1 over n, this particular base, this particular power is going to form roots, either cube root, square root, fifth root, and so on. Yes. For example, we have 8 raised power 1 over 2. Like I said, the denominator of the power, which is 2, will form roots. We are going to be having square roots of 8 raised power 1. The 1 is the one that is here. So if we have let's say 64 raised power 1 over 3, that means we obtain, like I said, the denominator of the power will form roots. In this case, it's going to form cube roots of 64 power 1. As we all know, the cube root of 64 is 4. You can use your calculator to confirm that. Now let's look at the last rule. Last law of indices says x raised power m over n. This simply means we can write it as x raised power m, and close bracket, 1 over n. And if we have this, we are going to, you can see it's following the previous law we just considered. That's the law 8, following law 8. In that case, this 1 over n, like I said, this one, which is n, will form roots. So we'll be having nth roots of x raised power n is what we obtain. For example, let's take a look at example here. We have 64 raised power 2 over 3. I can simply write it by saying 64 raised power 2 times 1 over 3. And that can follow the 8th law and write it as 64 raised power 2, everything in bracket of 1 over 3. Therefore, can give us, in this case now, we apply the law. You can see this one will form root. That will give us cube root over 64, everything squared. So the cube root of 64, as we have discussed the other time, is 4. But we are still having square. So that will give us 4 square, will give us 16. So by simplification, 64 raised power 2 over 3 will give us 16. Alternatively, we can solve this problem using another approach like this. We have 64 raised power 2 over 3. I can write it. What is the indices of 64? That will give us 2 raised power 6 as 64. Then we are now having 2 over 3. That's what you have there. So 6 can divide 3. Yes, 3 in 3 will give us 1. So will give us 2. So I'll be left with 2 raised power 2 times 2. And that gives us 2 raised power 4. So 2 raised power 4 will give us 16 as well. You can feel free to pause the video and go through it. Let's take a look at the last example. We have 16 raised power minus 2 over 4. We have 16 raised power minus 2 over 4. How do we go about this? Change the ink. The first thing is we are having a negative power. We have to apply the law. I told you that the negative power indicates 1 over. Then we write our function back as 16 raised power 2 over 4. Now, let's apply the laws. You can use as you can see on the screen. Feel free to pause the video and try working it out. You can solve it this way. 1 over the indices of 16 is 2 raised power 4. Then I'm still having 2 over 4. That is 1 over 2 raised power 4 can go in this. That is 4 cancel 4. So I'll be left with 2, and that will give us 1 over 2 raised power 2. Sorry, we cancel this. 1 over 2 raised power 2 will give us 4. Another approach to solve this question is by applying the law 16 2 raised power 4. That will give us 1 over, like I said, that will give us 16 raised power 2 everything over 4. Yes. So now, sorry, 1 over 4 rather. Now this is following the law that we have considered by saying x is power 1 over n, and that will give us nth root of x. We have considered this. So let's try to apply the law here. So this is our n. Like I said, it's going to form root. So we're having 1 over 4th root of 16 raised power 2. So by simplicity, we're not supposed to use this approach because it's kind of big. But with the help of our calculator, we can simplify it. Saying 1 over the 4th root of 16, when we punch our calculator, is 2. So we left with the 2 that is there. And that it will give us 1 over 4. Yes. So we have considered the laws that govern indicial operations. Yes, without these laws, we won't be able to solve many questions as a matter of fact. So let's take note of some things that we are to look at. Should take note of this. I call them gist. Yes. Let me gist you. Let's take note of the first one. If you have, let's say we have x plus y raised power n. It is not equal to x raised power n plus y raised power n. You have to be mindful of this expression, because if I write 2 plus 3 raised power 2, it is not equals to 2 raised power 2 plus 3 raised power 2. Let's try to work it out. Let's start with the first step. 2 plus 3 whole square simply means 2 plus 3 will give us 5. And we have square. And that will give us 5 square will give us 25. When we write it like 5 in 2 places, 5. Yes. But if we consider the right hand side by saying 2 square plus 3 square, that will give us 2 square will give us 4 plus 3 square will give us 9, and that gives us 13. So 25 is not equals to 13. So you have to be mindful of that expression. Let's look at the second key point we need to consider. and that is x minus y everything raised power m. It is not equals to x raised power m minus y raised power m. So it's not the same thing. It's not. So for example, you have x raised power x minus y raised power 2. We can't write it as x raised power 2 minus y raised power 2. It is wrong. It is wrong. They are not the same thing. It's because x, let's take a look at it. The first one, x minus y raised power 2, simply means we are having the function x minus y and x minus y in two places, and that we can simplify by opening the bracket, and that will give us can feel free to pause the video and try opening bracket. X square minus 2xy plus y square. That's what we obtain. Yes. So, but on the right hand side, which is this, the right hand side, we are having x square minus y square. So the left hand side, which is this, is not equals to this. So this, we have been able to talk about the indices and the laws that govern indices. In the next video, we are going to be examining questions, problems regarding all these laws that we have discussed. Thank you. Feel free to subscribe to my YouTube channel for more videos.